Hi everyone. I am Potch, or Matt Claypotch. I am a developer advocate at Mozilla, which sort of, is developer relations plus a lot of feedback collection and going back and informing our priorities for web platform and Firefox features. I've been at Mozilla for about 7 years, and today I'm going to give you a short update on what's going on in Firefox sort of as we get about a third of the way into our year. 2017 is a huge investment year for Mozilla in Firefox, particularly around Gecko, our rendering engine. Gecko has been around for a long time. It sort of predates many other browsers. It's just the rendering engine itself. And it's getting a little long on the tooth. So we've been undergoing a couple big multi-year projects that are really starting to bear fruit this year to completely update and revitalize the engine and make it ready for the next 10 to 12 years of browsers. So we're Mozilla. We're a nonprofit organization, and our goal really is to keep the internet healthy, open, and accessible to everyone. The way we do this is by making Firefox, as well as all kinds of extra advocacy work that we do sort of on the nonprofit side of our organization. So the big project for this year is Project Quantum. And what Project Quantum is an attempt, like I said, to really retrofit and modernize huge swaths of Gecko, the rendering engine, in Firefox. The beginning piece of this started to land last year, where we moved to a multi-process architecture, which pays big dividends in terms of stability and security and performance. And now we're starting to actually make significant changes, not just to the architecture of our processes, but actually the individual rendering pipeline pieces in the browser. So how are we doing this? We have an experimental browser that we're working on called Servo. It's built using the language Rust, which is a Mozilla-sponsored project. And Rust tries to make parallel computing more safe by default, tries to include memory safety features out of the box. If it compiles, it has memory safety guarantees. And all of these things make it easier to write parallelized and concurrent code that it would be a big nightmare with a big hairball of C++ and C. So Servo is this, what if we started from first principles now and built a browser? And the answer is, you can do a lot of things that really weren't feasible in the past, including taking advantage of all these awesome cores on our devices, right? And even our mobile phones now have multiple cores. Moore's law is sort of broken. And we need to start taking advantage of things beyond the single-threaded performance on the web. So there are a lot of ways to do that. We're focusing mostly on browser internals right now and not as much on the actual JavaScript execution. But the hope is, by making the browser faster, we're making 10 louder, we can make it possible to take existing web code and just handle it more gracefully. And that hopefully gives developers like you more headroom to make high-performant websites. So one of the big pieces going to be landing this year is a project called Quantum Style. It comes from the observation that when styles change on a page, either due to animations or DOM updates or DOM insertions, those style computations can largely be computed in parallel. So we're actually going to start using multiple processes or multiple threads within a process to recompute style on the page in real time. This means two things. One, we can compute styles much, much faster. And on mobile devices, we can actually split the work up over threads and perhaps compute it at the same speed, thus requiring a little bit less clock power and actually reduce battery consumption for the same style computations. Quantum Style is expected to land in the next 2 to 3 months. And while you may not necessarily see big, huge performance leaps forward in your frame rates, hopefully with large batch DOM updates, you're going to see big improvements in how fast styles get applied, and hopefully the sort of recomputing style portions of your timelines are going to get a little smaller, and that's going to give you more headroom to make smooth online experiences. Another segment is Quantum DOM. What this is actually doing is really going in and changing the way in which multiple browser tabs interact. So in addition to moving to multi-process models, where two browser tabs can interact or can both run without interacting, we're also going to do some stuff just to overall reduce the sort of footprint on your computer and resource usage of Firefox. The big three pieces are prioritizing browser tasks. So most important ones run first. Those are responding to user input, handling in-page events on the front tab, all kinds of things that are going to be super performance critical for users in their real-time usage of your app. We're going to delay running code for background tabs. We're actually going to potentially start throttling tabs that are running in the background to make room for high priority foreground tab activities. You have to be very sensitive here. Obviously we don't want to disrupt music playing, if someone's listening to music in a background tab, but we do want to reduce the consumption of resources by background tabs. We've done a little research and determined that about 50% of background tab activity is tracking scripts, and I don't think anyone will be too sad if those get throttled a little bit. In addition, for things that are really slow, we may actually preempt them and say, okay, we're going to pause execution of this background task where it is, freeze it in space, and then jump over to our important foreground tasks and actually preempt that code and not even let it finish, but then pick it up where it left off when there's a little bit of breathing room on the main thread. The last thing is Quantum Flow. Quantum Flow is just a big grab bag of performance improvements in Firefox. When you move to a multi-process model, you have to do all these inter-process communication calls, and a lot of those, even though they're asynchronous, they're still ultimately blocking. You can't do anything until setting a cookie, for instance, is actually successful. So we're actually doing a ton of work to reduce and remove as many of these sort of synchronous IPC calls as possible, and we're really focusing on high complexity DOM-based web apps like Google Apps or Twitter.com or Facebook, and hyper optimizing those and sort of making sure that the most performance critical and most high use web applications run as smoothly as you would like them to. So what else are we doing? That's where I have more here. There we go, just looking a little laggy. So we in Firefox 52, we launched the initial implementation of WebAssembly. And WebAssembly, if you are not familiar, is the ability to take compiled languages such as like C, C++, and Rust, and a bunch of other languages that are, the long tail of languages, and run them into the LLVM compiler toolchain. And at the end, you output a compact binary format that is recognized by JavaScript engines. So we sort of redubbed our JavaScript engine really sort of a WebVM, because in addition to running JavaScript, it now has this parallel pipeline for running WebAssembly code. This means high performance or super timing critical pieces of your application can be written in another language and compiled down and sort of running in this non-garbage collected high performance environment. Other browsers have already committed to or shipped implementations of WebAssembly. Chrome has shipped implementations of WebAssembly. I believe we have commitments from all the other major browsers that they are going to, if they haven't already. Forgive me if I haven't mentioned your browser and you have already shipped. It's going to, the big thing is we're going to unblock web games, right? No one needs to download the Unity plugin to run a game written in Unity, because the game will actually compile down to WebAssembly. We have some existing tool chains that already do this. In addition, we're hoping framework authors will take the mission critical pieces of their application and perhaps write them in these compiled modules, which can call back and forth into user space JavaScript. So you can have a framework that maybe needs to do a complex diffing calculation on a static DOM tree or what have you, and we'll write that in compiled code and let that run, let that be called into by your DOM side operations. So you can go compute your important complicated diff very, very quickly and then jump back into JavaScript code to apply those changes. We also recently, in Firefox 52 in March, launched async functions and the await keyword. I'm going to go a little bit into these because I'm really excited about these. I think they really, really fundamentally change how we architect our JS code. For instance, here's sort of a common callback style, workflow here. It's a little bit of a pyramid of doom, and I did that a little bit intentionally just to demonstrate what we're getting into right here. So we have a function where we're trying to get our user, and then if we get our user and there wasn't an error, we can go get the profile based on the user's ID, and then we can grab the profile and display it, or if there's an error in a couple different places, we can catch that error and handle the error gracefully. So obviously, promises are part of ES6, and all browsers support them. So how would this look with promises? It's actually much, much more compact already. We're going to get a user, and we're going to wait for it to finish, have that .then, grab that user, and then continue down the chain by returning the get profile for the user ID, just like before. And at the end, we can catch all those errors and sort of pass them into our error handler. This is nice, but it still doesn't look like if you have all been synchronous code. And I think the beauty of async functions and the await keyword is you can really sort of write async-looking code with very clear, easy-to-understand control flow, but actually make them be asynchronous under the hood. So we've got an async function now, and that async function can try the following two tasks. It can just do an assignment where we await the call to get user, and that's actually waiting for the promise underneath the hood to resolve. And then we can take that user object and we can await getting the profile based on that information. And you can see you can just call functions, you can just do assignments, and wherever you drop that await keyword, we're actually going to pause execution of this function, go out and do the asynchronous task, and come back with the results. And if that promise rejects instead of resolves, we can catch that error using the catch keyword. You can actually, it's a little bit easier than worrying about you didn't either you'll catch it like this and you can handle the error, or it will actually end up becoming a throw. I know a lot of people are concerned about error handling in JS, and especially with promises, where promises don't really throw by default. And by using the await keyword, you are going to get a throw out of this. Now, granted, you'll have to catch it at the next outer layer, but it is sort of more familiar ergonomics for people who are familiar with the traditional synchronous JS flow. So just really quickly touching on WebVR. This is something that we've been working with other browser vendors, including Samsung, and we've been working with Chrome on this. And it's actually a small W3C community group working on VR. It's a set of JavaScript APIs that let you discover and interact with virtual reality hardware that's connected to your computer. We have support for the HTC Vive, working on support again for the Oculus and the Oculus Touch. And we just announced support that actually in Servo, we have experimental support for the Google Daydream headset, which is really exciting. And we're going to get that support actually back into mainline nightly Firefox as well. It's really, really cool to be able to make just a web page that can all of a sudden become this immersive experience. And that, coupled with WebGL, really lets you build these beautiful immersive worlds that can be delivered over a URL. I think the URL distribution model, even John Carmack has said, is the sort of the killer app for the web, right? I can click your link and be in your VR experience in seconds. It's a really, really fantastic experience, and we're looking forward to see what developers build with it. Speaking of WebGL, WebGL 2 shipped in the past quarter, and it's sort of an extension of WebGL 1. WebGL 1 was OpenGL ES2, and WebGL 2 was OpenGL ES3. The numbers don't line up, which sort of stinks, but what it means for developers is more modern shader features, more modern texture features, better particle support, and some additional optimizations that make your actual graphical computations and graphical renderings go a little bit faster. We have a bunch of demos out there. You can look up. If you look for WebGL 2 demos online, this one is After the Flood. It's a really slick demo of sort of a post-apocalyptic city with floating islands. I feel like floating islands are the sort of hello world of WebGL rendering demos, but this is no exception. And you should really check it out. If you're used to writing WebGL and you're comfortable, it's going to be just a little bit of new stuff to understand, and we're hoping that JavaScript frameworks that wrap WebGL will start embracing these new WebGL 2 features and just sort of abstract those away for users who are more familiar with a tool like Three.js. A couple other things to look forward to this year. We have the Tor uplift, which is actually sort of a project to take all that big hairy change set that is applied to the Firefox codebase to make it into Tor, the anonymous browser, and actually uplift a lot of that code into Firefox and make it build time configuration. This is going to reduce the risk to the Tor project of having sort of at patch time introducing vulnerabilities and security issues that reduce the anonymity of the Tor browser. It also means that some of those cool privacy features, like first-party isolation, will actually be in Firefox, and we can start providing users with more privacy and security features that sort of building on all the great work the Tor community has done. We're also committed to strong sandboxing on all platforms this year. We've moved to Sandbox Stage 2 on Windows. It's an extra bit of isolation, and we're going to have strong sandboxing up to Stage 3, as we call it. I know it's a bit jargony, but it means sort of modern, full-class tab browser process sandboxing. We want to make sure that our users are not at risk opening web pages on the internet. We want to make sure that our browser is not vulnerable to crashes when web pages go haywire. We've also got some web platform features. Web Payments API, I can say is in progress. We have a group of people working on it right now. I don't have an estimated landing time for that, but I think we're really excited about web payment request, and we think it makes e-commerce and sustainability for websites so much better that it's kind of a no-brainer to get implemented. And we've committed to shipping that, and it's in progress. Additionally, for WPAs, we actually have these PWAs, WPA is security. PWAs, we actually now have add to home screen for on Firefox Android. What this means is if you are on a site that sort of has an app manifest and has a service worker, the user can be actually request to have that added to home screen. We haven't implemented all the heuristics for prompting, but users who know what they want can go add PWAs to the home screen on Firefox Android if they use Firefox. And additionally, this is not really a web platform feature, but we announced just about a week ago that we are going to be eliminating our Aurora release channel. What that means is right now Firefox has a 4-stage release process: nightly, Aurora, beta, and release. We're actually going to be removing Aurora. The hope with Aurora was to have about 10 times the users we would have had in nightly. Unfortunately, that never really reached fruition. So we're actually going to be focusing on more automated testing in nightly and concentrating a lot of our testing cohort of user testing in our beta channel. If you use Firefox Developer Edition, like I do, Firefox Developer Edition will now be based on the beta channel as opposed to the Aurora channel, so you can still expect that same experience. And we've taken the compact theme from Developer Edition and made it available just as a Firefox theme. So if you want a little bit more screen real estate from your browser, you can enable the compact light or dark themes. So all the goodness from the Aurora channel browser is now baked into Firefox across the board. And we're going to move from 18 weeks to a 16-week cycle or 12-week cycle. So new features are going to get to users faster. And lastly, I wanted to quick pitch web extensions. It's a sort of embracing of the Chrome model of browser extensions. We're actually trying to work with the other browsers to standardize web extensions, so you can really write one code base to extend browsers the same way you can write one standardized code base to build websites. This is still early work around the standardization process, but we have sort of announced that we have reached 98% Chrome parity, and there's great tool chains available, such as the web-x npm tool that will actually do a lint and tell you whether your existing Chrome extension code base will now work in Firefox. We're also adding a couple APIs for Firefox-specific features that aren't in other browsers, but we want to make sure that there's a big, nice, rock-solid, standard, common core that lets developers write one code base and deploy it across all of their users or all their browsers. I'm really excited about that because I love that model I love the worker model of building extensions, and I love the DevTools integration. So that's it. I am Potch on Twitter. If you have any other questions, you can ask them now or follow up with me later. So thank you so much.
Hey there. Are you into reactive programming using JavaScript? Do you have to deal with asynchrony in your web app? Then join This.instructor Ben Lesh to learn all of the ins and outs of RxJS in his hands-on workshop. Available online and in person, go to rxworkshop.com for more details and to book your spot today. Hey there. Do you use Angular? Do you like fun in the sun? And how do you feel about boats? If you're nodding yes, then come join us on NG Cruise to learn more about Angular while on a fabulous Caribbean cruise. Check out ngcruise.com for speaker lineup, workshop details, and to book your spot today.